Okay guys, let's finish up our 4.3 notes here. So we need to open up StatCrunch, and I've saved this data and shared it with you under my name, Boston Flight. This should say times. It's Boston Flight times. So to load shared data, we go under here. You can search my name, and then you can find the appropriate one. On here it's named correctly, Donahoe Boston Flight times. So here's that same data, just input in here. So what we've got is we have flights, all these flights are from Boston to these particular cities. This is the distance in thousands of miles. So this is 1.141 thousand miles, and then this is the time it takes to travel that in hours. Okay, we want to do a complete regression analysis on this and then ultimately figure out how long it would take to fly from Boston to Seattle, which we know is 3,000 miles. Okay, first question, which should be the x variable and which should be the y variable, and why to these? Well, if you're given information in a chart, usually you're safe to say x is the first column, y is the second column. And there's another reason for that as well. We are trying to use distance to predict the time. So this is going to be my predictor, or my explanatory variable, or my x. So distance is going to be x. Time is what I am trying to predict. It's my response, so that is my y. So you can add that information right here. Okay, first things first, we want to make a scatter plot so that we can see if the trend seems linear, or if there's a curve. If it seems linear, we can proceed. If there is some sort of a noticeable curve or some other shape happening, then we would have to stop. So the first thing we want to do, is a graph. We want to make a scatter plot, distance x, time y. Looks pretty linear to me. Looks very linear, actually. It looks like a very strong linear trend. Okay, so now that I've visually inspected that, I know it's safe to proceed. So it says, if it appears linear, find the regression line and write it here. Okay, so we need to go under our stat regression simple linear again. Same place we were finding that r value in the last section. X variable again is distance, y variable is time. And here's all that information again. So before today, the only thing we were looking at was this r value. That's still important to me. R is 0.9947. So it is I'm going to go ahead, I'm skipping for a second. That answers part E over here. What is the correlation coefficient? That's that r value. Is this a strong trend? Absolutely. This is a very strong trend. That number is very close to 1. So it is a very strong positive trend. Here is my equation. This is the regression equation. Again, remember that entire thing, that whole line is your equation. Time equals, then you've got your 0.839 plus 1.837 distance. You need the time, you need the distance. That's part of your equation. Those are your variables. And notice up here, it even helps you out a little bit. It tells you which one's dependent and which one's independent. Okay, so we'd write that entire thing right here. All of this goes right here. We've already talked about, yes, it's strong. Interpret the slope in context. So again, I'm going to be saying this verbally to you and not typing it in here right now. But which one of these numbers is slope? You need to know that slope is always the number in front of your input variable. But notice that you got a little cheat here. Even if you forget, it tells you right here, slope is this number. So I need to interpret that 1.84, let's say, in context. Well, let's see, I actually am going to type it in over here for us. So in context, what does that mean? That means for every one additional x value, so for every 1,000 additional miles traveled, we expect the time to increase by that many hours. So by about 1.84 hours. That would be my slope in context. For every one additional, whatever my x are, we expect the y to increase by whatever the slope is. Interpret the y-intercept in context, okay? Again, I should just know that this is the value, but in case I forget, it tells me right here. That's the value. So the y-intercept is 0.84, let's say. So in context, what does that mean? Well, first remember that y-intercepts are of the form 0, comma, that value. So what I might say is something like, even when the distance traveled is 0 miles, we still expect a time of 0.84 hours. Okay, now sometimes this y-intercept makes sense and sometimes it doesn't. So does this make sense? Sure it does. Think about, have you ever been on a plane before? Before you ever even take off, isn't there some time that is used? Yes, there is. That's like the announcements, loading, etc. time. So that does make sense. Sometimes this doesn't make sense contextually, but I think in this case it does. How long should it take us to fly nonstop from Boston to Seattle? Well, we're going to use our regression equation that says this. I'm going to see if I can copy and paste it over here. Oh, I can. So how long, we're trying to find time when we know that the distance is 3,000 miles from Boston to Seattle. So I'm just going to put a 3 there because, again, we're counting in thousands. All of these were in thousands, so I just need to put a 3 right here. And then I grab out my calculator. I use that, and what I get is I get 6.35 hours. So ultimately, that was the final answer we wanted to give there.